Hello, welcome to Math Solutions Not So New Math Series. My name is Brandon. Today we're going to be talking about multiplication, more specifically representing multiplication in order to develop that deeper conceptual understanding. Now, why do this? Multiplication traditionally, when I was in school and when many of you out there were in school, was taught mostly through rote memorization. I remember being in third grade, having to stand up in front of the class and recite my multiplication facts until I got from my zeros through my 12s. Well, we now know that that is not the most effective way to learn. It's better to have students understand the concept behind mathematics, the concept behind multiplication, so that they have a sustainable understanding that they can take as they progress through the grades and the math concepts that attach to multiplication. So what I'm going to do today is talk to you about the use of a 4 square in order to help develop that deeper conceptual understanding.
Representations of multiplication. Before we get started with this, I'm going to encourage you to pause this video and go grab a sheet of paper and a writing utensil. That way you can follow along with me. And I have a couple of questions that I'd like to pose, and these are for you to think about as a before and an after. Kind of a, do I have an idea of how to answer these now? And then at the end of our little session, you can ask yourself the same thing. Do I have a better understanding? So the two questions are, what is multiplication? And can you name 4 representations of multiplication? And I know for a fact afterwards you'll be able to name 4 representations because we're about to go through 4 now. So if you grabbed a sheet of paper, take that sheet of paper and draw a rectangle directly in the center. And then that's where we're going to put our expressions. So we want to also have 4 sections, one for each representation. So I'll put a couple of vertical lines in there, section it off, and then we'll put horizontal lines so we can end up with our 4 different quadrants, one for each of the 4 representations we will do. Today we're going to focus on the expression 3 times 4, and that expression has a reciprocal, or it has a commutative property version of the same quantity, same value, which means we switch those factors around and we end up with 4 times 3. So I have both expressions right there in the middle. Now we're going to talk about our first representation, and the first way we are going to represent multiplication today is pictorially. Pictorial representations are a really great way to start developing that conceptual understanding and a good way of thinking deeply about this mathematics. So when we talk about 4 times 3, that's kind of like saying 4 of 3 or 4 groups of 3. So I want to make a representation pictorially, which is going to be equal groups. So if I have 4 groups of 3, that means I need 4 groups. So I'll draw 4 groups as circles. 1, 2, 3, 4. And then inside each of those groups, we need to represent the quantity 3. We need 4 3s. So I'm going to subitize my representation. And subitizing is a great way for us to represent quantities that can be easily recognized. So we can subitize like we do on like quantities represented on dice, dominoes, and playing cards. Or we can also subitize with things like tally marks. We can subitize with our fingers by showing a hand signal or a hand gesture for a quantity. We can also subitize in one of the newest ways with the idea of 10 frames, or I like to say 5 in a row and the rest below. I'm going to use dice, dominoes, and playing cards because we're only working with the quantities 3 and 4 right now for our pictorial representation. So I'll put 1, 2, 3 dots in each of these 4 groups. 1, 2, 3. And now I've represented 3 in 4 groups, or 4 groups of 3. So we have 3, 6, 9, 12 dots. So 4 times 3 is 12. Well, we also know that the same is true for 3 times 4, that it should be 12, but we're going to represent this now with 3 groups of 4. So I don't want to use the same shape I used for my 4 groups because then it will look at a glance like 7 groups, and that's not really what I want to do. So I'm going to change from a circle to a square. So we'll have 1, 2, 3 groups, and then in each of those groups we need to put 1, 2, 3, 4. And now it's really starting to look like dominoes and dice. So now we have 4 groups of 3 is 12 and 3 groups of 4 is 12. After equal groups, this is a pictorial representation. Let's transition now to an abstract representation. So if we're talking about representing abstractly, that means we're going to be using those symbols of the world of mathematics, or those digits and those different symbols that we use when we use the language of mathematics in a written form. So instead of making 4 groups and putting 3 in each, I want to make 4 groups of 3 by using that abstract representation, the digit 3. So I'll take repeated addition. I'm going to repeatedly add 3 4 times. And the same is going to go for my 3 times 4. So I need 3 groups of 4, or 3 fours. So I have 4 plus 4 plus 4. And you can represent this with an expression like we did with our 3 plus 3 plus 3 plus 3, or with an equation like we did with 4 plus 4 plus 4 equals 12. And depending on how my students put their information in this quadrant, I'll question them to try to get them to use both, or to understand that there's both ways of representing. So these two are great. We have equal groups, our pictorial, and repeated addition, our abstract, but I want to transition to another level, or a little bit deeper level of understanding multiplication, and that means that we're going to transition to that rectangular representation, because multiplication and division can be represented as a rectangle, and a specific way that we do that is by making a pictorial rectangle, or an array. Now there's 2 words that go with an array, 2 words that I really try to get out of my students. I call it going dental, because it's kind of like pulling teeth sometime to get them to say what you want. But I'll question them until I get to the point of them telling me that an array is represented with, yes, rows and columns. So we need to create rows and columns, a rectangular array, to represent 4 times 3. That means I'm going to put 1, 2, 3, 3 dots to make 3 rows, and then I'll put 4 dots in each row. So we have 2, 3, 4, 2, 3, 4. And there we have 3 rows with 4 columns, making a total of 12 dots organized into a rectangular array. And we'll do the same thing with our 4 rows, 1, 2, 3, 4, and then put 2, 3, 2, 3, 2, 3, 2, 3 dots in each of those rows to make 3 columns. Again, an array with 12 dots in a rectangle. So just like we did above when we went from our pictorial representation with equal groups to our abstract representation with repeated addition, we want to do that same thing down below. We made a pictorial representation of an array, but we need to make an abstract representation of that array. So what shape do those 2 arrays look like geometrically? If we define that shape, we define it as, correct, a rectangle. So we're going to make an area model, area of a rectangle. So draw yourself 2 rectangles, one that's longer horizontally, like our 3-column array, and one that is taller or longer vertically, like our 4-column array. And then instead of putting dots, we're going to label these abstractly with those digits again. So we have 3 rows, that's going to be a width of 3 for our rectangle. And we have 4 columns, that's going to make a length of 4 for that rectangle. And total, the array is made up of 12 dots. So I'm going to put inside there that we have an area of 12, or A equals 12. Now I don't really care too much early on if my students are going to write A equals. What I'm mainly worried about is that they're recognizing that we have a length and a width that are defined, and we have an area, and we put that in the middle. Same thing's going to go for our other rectangle. It has 4 rows and 3 columns, again, making a total of 12 dots as an area. So we've represented our multiplication now in 4 ways. I would like to encourage you to try doing the same thing, doing 4 representations, but what are some other representations you might use? Or try with some different expressions, these same 4 representations. When you do so, if you'd like to take a picture or a video of yourself doing this and post it to the comments, we would love to see what you've got. Don't forget to use the hashtags InspireMathCulture and Not So New Math. Thanks, and join me next time when I'm going to do a 4 representation version of division.